Hello students and welcome to Pradeep sir classes as PSC where logo can talk the physics. And students, we are in the next numerical, that is question number 50 and the numerical king series day 29. Okay, so I always suggest you that please follow that particular numericals day by day and your concepts about electric field and potential, about Gauss's law and about the potentials, and day by day increasing greater and build up your concepts more rigid. Okay, so let's start with question number 50 and write down the question first and then try to see the answer. So question number 50, the bob of a simple pendulum has a mass of 40 gram and a positive charge 4.0 into 10 to the power minus 6 coulomb, and it makes 20 oscillations in 45 seconds. 20 oscillation in 45 seconds, and a vertical electric field pointing upward, and the magnitude is switched on. How much time will it take to complete a 20 oscillation? Okay, so first of all, students, you have to draw the pendulum. You have to draw the pendulum. So this is a pendulum and it oscillates 20 takes 45 seconds. It takes 45 seconds to complete 20 oscillations. Okay, so this is the angle of inclination and this is the length of the pendulum and this is mass, so weight acts along this direction, and we know that the time period of oscillation is, yes, it is t equal to 2 pi root over of L by G. Okay, it is this one, and according to this equation, if we substitute the time period here, then you can calculate length, but you have to calculate the time period for the next one when the electric field is switched on. So its effect on the acceleration of the body, that is when an electric field is switched on, then it is experienced, the bob, since it is a charged bob, then it experienced a upward force, and this is equal to QE. This is equal to QE. So the resultant force will be mg minus of QE, and if we calculate the acceleration, then you have to subtract with the mass of this one, then you can get g minus of this acceleration. This is the resultant acceleration, and we can say that this is g dash. Okay, again I repeat, students, this is a pendulum and it oscillates, and the time period according to this is this one, but if the electric field is switched on, then the electric field along this direction can exert a upward force on the bob, since it is a charged bob. So QE force act along this direction, but still it is oscillating, so the resultant force act on that particular bob is mg minus QE. Hence its acceleration due to the effect of the two forces, that is mg along downward direction as well as the QE along upward direction. Okay, so these two forces act along two opposite direction, and due to that particular one, the acceleration of the bob changes, and that will be g minus of a. So the new time period will be 2 pi root over of L by g dash. Okay, so the previous one is t equal to 2 pi root over of L by g, and after switched on the electric field, it will be t dash equal to 2 pi root over of L by g dash. So the time period will be t dash by t. If we divided this and this one, then you can see that this will be root under of g by g dash, and 2 pi cancel, and root over of L that is the effective length, is also cancel out this one, so you can easily calculate that is the value of this one. So it is T dash equal to root under of, and we can write here also, so this is equal to root over of G by G minus of A, G by G minus of A, and this will be, so this will be root over of G means 9.8 by G means 9.8, and you have to calculate the acceleration from that particular one. So acceleration equal to QE by M, and here charge is also given as well as the electric field is also given. So the charge is, question number 50, the charge is 4.4 microcoulomb, that is 4.0 into 10 to the power of minus 6 coulomb, and the electric field is 2.5, and we can erase that particular one. Okay, here, so it is this is equal to, acceleration will be 4 into 10 to the power of minus 6 into electric field, that is 2.5, that is 2.5 into 10 to the power of 4 by mass, that is 40 gram, so 40 by 1000, and this is kg, and it will be 2.5. okay, it will be 2.5 meter per second square, since this and this equal to minus of 2, and this and this one cancel, 4 cancel, and when 100 goes from this and this also cancel, so 2.5 meter per second square, and you can subtract here 2.5, and this is equal to root under of 9.8 by 3, and this is equal to 7.3. okay, so 7.3, and this is equal to, so this is equal to T dash equal to T into, this is the value 9.8 by 7.3, and this takes, the time period is 245. To complete the 20 oscillations, it takes 45 seconds, I think. So 45 by 9.8 by 7.3, and you don't have to divide it 45 with 20, because the questions is that, and the next time how will the pendulum takes to complete 20 oscillations within 40 seconds. So T dash is the seconds, and this is equal to an approximate, this will get 52 seconds. okay, so 52 seconds, these calculations takes a value of 52 seconds. okay, so 52 seconds is the next time period. Again I repeat the numericals. There is a pendulum and it oscillates, it takes 45 seconds to complete 20 oscillation. okay, so 20 oscillation, it takes 45 seconds, and the question is that if an electric field is switched on suddenly, then what will be the time period? Then first of all, students, you know that the time period is T equals to 2 pi root over of L by G, and the second one is T equal to 2 pi root over of L by G dash, where G dash is the new acceleration due to the resultant force of this Q along this direction, QE along this direction, and the downward direction it is mg. So this will be G dash, and G dash equal to G minus of A, where A equal to QE by M. okay, and this gets 2.5, and if you substitute that particular value, then it is 9.8 by 7.3, this leads to a value of 52 seconds. okay, so this is the answer, and students, obviously, for welcome for the next numerical. Thank you.